Okay, I think we're live. I think we are finally live. Let's check this out 1 second. Double checking we are live.
Welcome to the Angular from Theory to Practice course where you're going to learn how to build a web.
Yes, we are live. Okay, I think we're live. Excellent. I think we are finally live. Let's give this... Excellent. All right. 1 second. So welcome to this. I think my first live share of many. So what I'm going to try to do in this live share is something that's quite nerve-wracking, to be honest with you. As in, start to go through the process of building an application without having done pretty much any research, if any significant value, into the project. So for me, that's pretty nerve-wracking. I never really go on stage or present anything if I haven't practiced it 1,000 times. But I was given some advice recently, which was people would like to see my process, my thought process, as I go through building an application from scratch. Now, I'm quite surprised anybody would ever want to see my thought process. It's not particularly a pleasant experience. But if you want to see my thought process as I go and build an application, here you go. This is Asim in its rawest form. So what do I want to build today? What I want to build today is something called, I'm calling it OK Asim. Okay, so we've all probably heard of OK Google. Like I've got an Android phone, or if you've got a Google Home or something like that, or there's Hey Siri, or there's all the other ones, or Alexa, all these other ones out there. And what you do with all these devices is you say something, like you say, okay, Google, or okay, hey Siri, or Alexa, or whatever. And that's kind of the trigger word, okay? And these devices are always listening for that trigger word. They're always listening. They don't really understand anything else other than that trigger word. And that kind of scares a bunch of people because like, oh, it's always listening to everything that I'm saying. Well, it's always listening for... okay, Google, Alexa, something like that. And because those devices, like my phone, only has enough knowledge, machine learning knowledge inside it, just to listen for OK Google. Once you say after OK Google, see, just that's it. If I figured out I said OK Google. After you say that, anything you say after that, that sound file gets sent to a server. And then the much more complicated stuff happens there to figure out, well, what did he mean? And it comes back as a command that you can get executed on your phone or whatever. So that's kind of what's happening. And what I always thought for ages, well, is it possible to create an OK Asim that runs from within a browser? I thought that'd be quite an interesting thing to try and do. And that's what I'm going to try and do. Now, I'm not 100% sure exactly how to build this. Not 100% sure how to build this, and that's quite nervous for me. But I'm going to give it a go, and you feel free to hang around and see this process. All right. So what we're going to use, we're going to use a technology called TensorFlow. I do know this. I know TensorFlow reasonably well. So TensorFlow is a tool to essentially run lots of computational things, basically maths, across a whole bunch of servers and using GPUs on your computer and kind of parallelizing them and doing things like that. Don't get scared by the name. All that a tensor is a multi-dimensional array. So you got like a 1D array, which is just a set of numbers, a 2D array, a 3D, a 4D. I've forgotten how many Ds you have to get to before you stop calling it a something D array and you start calling it a tensor. But all that a tensor is a multi-dimensional array, and that's what it's all about. It's about how do you run kind of calculations on multi-dimensional arrays, essentially matrix calculations, which is a lot of what we do in machine learning, is just matrix calculations. So the technology we're using is called TensorFlow. The original version of it is written using C, so you can't really play around with it in JavaScript, but very excitingly, about a year and a bit ago, they launched TensorFlow.js, which is available for JavaScript. and that's what I'm going to be using. So I know a little bit how I'm going to start. I'm going to take us there. So if you go to the TensorFlow.js thing, which is TensorFlow.org/js, hopefully this resolution is okay. TensorFlow.js. Do you know what? I'm going to change the resolution. Let's keep it. I hate it when things are too small when I'm looking at stuff. So let's get this resolution. Yeah, much more like it with my eyesight. Ooh, that's not good. Excellent. There you go. And if you go to TensorFlow.org/js, you'll find a whole bunch of information about it. It's been really interesting, exciting seeing this project grow over the last couple of years. It's been really interesting. So you can go to tutorials, find the tutorials. There's a bunch of pre-trained models that you can use. So you can train machine learning models. You can do machine learning using TensorFlow. But what's really exciting in my side, what's really inspiring in my way, is to use one of the pre-trained models, and that's one of the really interesting parts about it. So the one we're gonna play around with. So I knew enough of this. I knew enough where to start. Is the speech command recognition module. Okay. So if you go there, this is the project. You can play around with it, do the stuff, and it tells you how to use it. At the very end, it's going to have something called, if I remember rightly, a live demo. We'll open this up here, and then we'll give this a go. Okay. So what this is a pre-trained model that's already been trained up to recognize a very, very small set of words. I'll see if it has the list here. Oh, here it is. So it can just understand the spoken, a few different words, and recognize what's being said. So it can't detect everything. It can only detect a small set of them, and it's basically being converted to be able to use inside JavaScript. So if you actually I've never actually dug into this actually, so let's have a dig in. See if anything here that is helpful. Oh, it's just the API. I mean, hopefully what you can see more than anything about this is it's just JavaScript. It's just a whole bunch of JavaScript here. Data set test. It's basically just a whole bunch of JavaScript, right? Now, in order to use it, we're just going to play around with it with the live demo that I just showed you. I think I opened up here. Here we go. And I think to begin, I press start. Yeah. Did you see that? Left. 5. 1. 7. Yes. Up. 2. Ah, isn't that cool? It's pretty cool, right? Of course, it's kind of few things. As I'm talking, it's detecting what I'm saying, so it can't really figure everything out. It's not perfect, but it's pretty decent. Pretty decent. So what I'm gonna do to begin with in this first session is let's just try and mirror what this is doing. What we then want to do later on is we're going to use a technique called transfer learning, which uses this data and lets us retrain it with just OK Asim. I'm going to explain how that works later on, but basically, you can imagine what this is it's a machine learning model, so it's kind of like a brain. It's a pretty dumb brain, pretty simple brain. And eventually, we're going to need a brain that can recognize OK Asim. There's two things you can do. You can either retrain a brain from 0 to understand OK Asim and nothing else other than OK Asim. Or you can take a brain that kind of a pretty dumb brain, but a brain that just knows this stuff, and you can go, well, actually, let's start off with this brain and then teach it just enough extra to do OK Asim. That is what we kind of call transfer learning. And it's quite useful because we never, retraining something from scratch is actually quite hard. But as you can imagine, taking something that's already kind of 80-90% of the way there and training it just for OK Asim, that's quite reasonable. And when we think and talk about what I think is going to be the machine learning kind of JavaScript role at some point in the future, I don't think it's going to be training something up from scratch. I think it's going to be take something existing and just retrain it a little bit to do to kind of add the functionality that you need, right? So that's where I think this space is going. That's my opinion. A lot of people, there's opinions are, there's a million opinions out there, but that's my opinion as to where things are going. And that's what I'll probably move on to in other sections, right? Let's start off now basically trying to recreate this. Now, what I'm going to do for this session is there is if we go back to, not the models, yeah, we go back to, I believe it's tutorials. So there is, yeah, if you go to tutorials, there's a whole bunch of tutorials here, and I recommend you can go through these yourself and learn them. What I'm going to dig into is build an audio recognizer. I think this is the one I'm going to go to. Yes, it is. Yes. And I'm just kind of going to follow through this to begin with, and that's kind of how I start. I know the eventual OKASM thing I'm going to build. This isn't going to teach me how to build that. Kind of, maybe it will take me some other way there. But it's always good, when I'm learning something like this, even with TensorFlow.js, I always start off with, let's just start off with one of their tutorials. I go through it. I don't really force it too much into going, but okay, Asim. I just kind of learn the basics, and once you learn the basics, then the ideas will come to me as to how to build the OKASM. So this is where I'm really entering kind of completely unknown territory here, and let's just give this a go. So I'm going to start the tutorial. So I'm going to open a link to the Colab, which is basically on Google's thing. It's just it's just kind of like a tutorial, basically. All right, so I'm just gonna basically go get started. So I'm gonna click next. Yeah, we're gonna need Chrome. I'll run it. Do you know what? I'm gonna run it locally on my computer. So you can use CodePen or Glitch or StackBlitz or something like that, which if you don't know what they are, they basically lets you run code online. Maybe I will do. Should I do StackBlitz or should I do local development? I'm going to do local development. Did I just kill the collab? I did, didn't I? That was clever of me. Let's do it again. Next. Let's zoom in on that one. Okay. So what I'm going to need, I'm going to basically need to have I need to have an index.html file somewhere. So I've opened up a Visual Studio Code instance. This is Visual Studio Code. Don't ask me what the theme is. Everybody asked me what the theme is. I actually can't remember. I installed it a while ago. It's just a theme. So in fact, I'm going to open up a terminal. Uh-oh. That is insane. I have definitely done that before. Let me open up another terminal in case it's going to ask me for a password. Oh, wow. Something interesting has happened to my computer. Okay, I'm running that command on another terminal so you don't see my password. It's completely unrelated to TensorFlow. Here we go. Oh, I suppose I should create a folder for this. So I'm going to just really quickly create a folder. I'm coding on a different terminal. I apologize. I'm going to call this project live stream. Open up folder. I'm going to open up this one. Okay, here we go. All right, so I have opened. The only difference between this and what you saw before is I've actually opened this up in a folder called OKASM. Yeah, OKASM. So now I'm going to create a file called index.html. HTML, right? And then let's open up this. Let's just whack that in there. Whack that in there. Let's zoom out a little bit. That's okay. So what's this doing at the end of the day? Well, what it's doing is it's loading TensorFlow.js. Okay. So that's the beauty about TensorFlow.js is that it's like TensorFlow, which I mentioned before, was written in kind of C, and is pretty hardcore, and you typically use it, across thousands of cores and lots of GPUs, and it's massively parallel, and it's intense number crunching. That's why it's written in C. TensorFlow.js is that completely written in JavaScript, and what that means is all you got to do is drop a script tag in, and you can be rocking in JavaScript and start doing some machine learning, which is fantastic. And the next thing I'm going to import here is the speech commands, which is the stuff I showed you before. So this model here, which is the speech commands model, so essentially it's loading up all of that stuff, which is basically the actual model itself and all the surrounding JavaScript that you need in order to, interact with that using web audio API and all the other stuff, all the other goodness that's coming from speech commands. And it's going to load an index.js. So let's just actually create an index.js as well. Okay. And I'm going to do console log moo, because that's what I do. That's what I do. Okay. And there's a couple of different ways. We now need to kind of run this. Now, what I always recommend when you're doing kind of stuff like this locally with index.html and index.js is don't just you could literally open this up by opening up in whatever kind of, I forgot what you call this, finders or whatever, and kind of just double clicking this. That technically does work, right? But it's going to give you issues. It's just going to give you issues, right? It's going to give you issues because it's loading a file. What you really want to do is you want to load this up using a web server. There's many ways of doing that. Many ways of doing that. I've opened up a terminal here. So if you're in Visual Studio Code, the way I like to use it is I've installed an extension called Live Server. So if you go to, I think this is extensions here, and you type Live Server, this is it. And then I've got uninstall, but you would say install. And once you install that, then you will have a right-click menu here saying open with Live Server. If you don't want to do that and you want to go like hardcore, and not hardcore, that makes it sound, it's just if you want to go a different way, which is using the terminal, you've got a couple of different options, especially on a Mac. So one of the ways is Python minus, if you've got Python installed, simple HTTP server. I think that's, if this works, it'll be fantastic from memory. Here we go. Yes. So that's one thing you can do, Python -mh. And if you've got Python installed, this will just work. Then what you can do is go to that port 8 and port 8000, sorry. All right. 8, 1, 2, 3. Okay, well you don't know, but trust me, that's working. Oh, you will know because I'm printed out in moo, didn't I? Oh, it's not loading a fav icon. Whoopsie-doo. So it's printing out moo, so you know it's working. Okay. And finally, if you want, and you can see some things here, so you know it's kind of actually working. And the other thing you can do is if you've got Node installed, right? Node, and maybe you do, maybe you don't. If you have Node installed, then you can use a tool called, I like to use a tool called Serve. Hopefully I've got it installed. I have. Called Serve, and that will serve everything in your local folder, and it will just print it there. And you can open up, and that's doing essentially the same thing. And if you don't have Serve installed, you can do npm install -g serve like that, and it will install it. And -g means installs it globally, if that's what you want to do. What the hell? Let me just install it because I seem to be on a older version. I complained earlier on. Yeah. Everything needs to be updated. Don't worry about it. So I'm going to clear that. So I'm actually going to use Live Server. So if I do Live Server, I just click there, and that's it doing it for me. So I'm going to close these other ones that I'd opened up. So just a couple of different ways of opening up. And just remember, don't click the index.html file from your Finder or Explorer if you're Windows or whatever. Don't just double click it. Do it. Open up a kind of a web server to do it, right? So that's that working. If I open it up, it should be console. Yeah, moo. And yeah, here it says live reload enabled. So I know it's working because I printed that moo. All right. Not doing terribly so far. Let's give it a go. All right. Next up. Kind of forgotten where I am. Oh yeah. Next up. So we've got just this working here. And now we've got index.js. All right. So we're good. We're good. Let's now go back to Colab and see what they say is the next steps. That's not the right one. This is the right one. Okay. Here we go. So next up. Ooh, whole load of stuff. Oh my god. They haven't, it's just kind of like, that meme, how to draw an owl. First you draw 2 circles, then you draw the rest of the owl. Maybe that's what this feels like. It's kind of a whole load of code here, isn't there? But what I'll do is I'll try and break it down. I think I understand enough of what's going on here to be able to explain it. So let me just go ahead and just copy and paste this in. And do you know what? What we'll also do is we'll drop in a couple of debug statements so we can figure out exactly what's going on. But let me, I don't need the terminal anymore for this one. All right. So what's going to happen here? It's going to go line 1, forget it, it's not going to do anything. This is just defining a function, that's call. It's going to go to line 22, it's not going to do anything. It's going to call app. It's going to call app here. App is an async function. Do I want to go into async functions right now? No. So I will kind of roughly explain what it means. But anyway, so then it's going to create a speech commands module, and it's going to be saying it's running in the browser. That's what browser FFT, which I believe is fast Fourier transform. So basically, it's going to be running, saying kind of it must be the engine to say how it wants to actually calculate things. So it's basically creating the speech commands module, which, if I understand correctly, that's what that's going to do. Is it's going to go on the internet, and then we'll check actually the network tab to see what's happening. I predict that's going to go on the internet. It's going to look for a kind of a model JSON file, and it's going to download that, and that's going to contain the actual kind of brain, that machine learning model, which knows like the data, it knows how to like understand things, and it's going to load that inside TensorFlow.js, and then it's going to wrap that inside some nice kind of speech commands module, speech commands code, so you can interact with it. And we're storing that in Recognizer. And then this must be what's going on. So that's creating it, and then ensure model loaded. It has this await thing, and what that really means is, like for the longest time, JavaScript was like a asynchronous language, which means that it could never wait for something. It could just never wait. We never ever wanted JavaScript to wait for anything. Otherwise, the browser would lock and then move forward. But now we have this kind of async await, and what that means is if there's an async on a function, and then you can do await, and what this does is literally will pause on line 24 and wait for everything to be loaded and complete, and then and only then will it move to line 25. So that's what this await is doing. I'm just gonna like be super cheeky and see if I can figure out what this is doing. So there's something called speech commands. So if I go back to, I don't know if I'm going to be able to grok this straight away, but I imagine speech commands, maybe index, that'd be the good starting off point. 1, 2, Here's the create function. So there's that create function that we're calling. See, it's not so scary. Like, we're always scared about, digging into a little bit of source code, figuring out what's going on. It is scary. It is. Give it a go. You'll be surprised. So we seem to be able to pass in. It's got a couple of other options actually we haven't taken advantage of, but you can pass in the FFT type. Let's have a look what that says. Type of FFT. The currently available options browser FFT. Okay. So there's only one option for this one, but it means it's probably future-proof for other things, and it's just saying using browser native Fourier transform. I'm not confident enough to explain what Fourier transform is yet, but that's what it is. Vocabulary. Oh, there's multiple vocabularies. That's interesting. So there is the 18 word vocabulary consisting of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, up, down, left, right, go, stop, yes, no. In addition to background noise and unknown, and we'll talk about background noise later. And then directional for up, down, left, and right. Did we have up, down? Oh, I see. There's the second one is just those four. Oh, okay. Choosing a smaller vocabulary. Yeah, that makes sense. If you only need to detect up, down, left, and right, then maybe that choice is better for you, right? Because it's going to be more accurate. That makes sense. A custom model. Custom metadata. I don't know what metadata is. Okay, so I know what the model is. The model is going to be. Let me see that. Hang on. I forgot to check if anybody's asking questions. Then maybe that choice is better for you, right? Because it's going to be more accurate. That makes sense. Somebody said hi. Hi, Frederick. I'm so excited, my first live stream. So what this is going to do is it's going to basically try and create the remote URL where the model is. All right, anyway, it's getting a bit boring. Let's go back to here. So that's what that's doing. And it's going to load the model. Then it's going to predict word. And then what's that going to do? Do you know what? Let's just run it. Let's just run it to begin with. See what's going on. Going a bit overboard there. Oh, that's what it's doing. See? 1. 1. 2. Let me make sure you can see that. Up. Down. Left. 1. 2. 6. Damn, pretty good, eh? So that's what it's doing. So basically, that code is basically then listening and then printing out, well, the letter according to what I've written. So let's just really, let's drop a debugger into this. Okay. And then let's give it another go and see what it says. In fact, I'm going to drop a debugger there. And just to save a lot of effort, I think there's another one. Yeah. Okay, let's see what that does. Okay. Let's zoom out. Zoom out a bit more. Okay. How can I make this easier for you to see? What if I do this side by side? Yeah, that's probably better. Okay, I don't need to see that. Here we go. That's a debugger. All right. So it has a little bit of hiya Pravankumar. Nice to see you. Yes, we're gonna like get some debugger. So I'm gonna roll over and let's see what does recognize a word labels. Okay. So what this is giving me is a set of numbers, and each number has a label, the string version of what that means. So in fact, like 7 is left, right? Which 2 is down, and 0 and 1 is background noise and unknown. So I'm going to guess, and it's going to that's so I can. The way models work, machine learning models work, is they only ever really give you numbers. And so if you want some text description, you have to map it somehow to some text description. It's never actually going to pump out a string. Tensors aren't strings, they're tensors of numbers. So this is going to be our mapping from a number to a string. And then it's going to start listening. And then I imagine every now and again, oh, where's my second debugger? It's not there. I'm going to drop a debug there, and I'm going to hit run. Okay, it's done it again. Okay, now let's do it again. Hello? 1. Okay, so something's happened. I'm going to look at scores. There you see. What it's generated, so it's listened for something, and then it's returning me a scores. Is it an object or an array? I can't tell. It's an array. With for each of the imagine to 19, yes, and for each of those, it's got a number next to it, which I assume is the probability of it thinking that's what I said. So you can see here, the probability is always from 0 to 1, well, usually from 0 to 1. I'd be very, very surprised if it's not from 0 to 1. So 10 is almost 1. You can see it's 0.99999. So what this is telling me that, it thinks it's 10. And I actually can't remember what 10 was. What did I even say? What did I say? I must have said 1. Yeah, I said 1. So then that's coming that way. Now, this is the way anytime with TensorFlow, with one of the models that kind of predicts something, like you've probably seen the ones that predicts text when you write it, or this one, the model never outputs just one. If it can predict one of 20 things, it will always give you an array of 20 things. And for each of the things, it'll give you a probability. It will always do that. It will always do that. It will never ever say, you meant 1. No, it's never that certain. It always says, 0.0.1%, 0.0.1%, 99%. It'll always say it in kind of that obvious way. And you think, well, why don't you just give me what you think is the most obvious? No, it always gives you, it's called categorical cross-entropy. It's the way the maths works underneath it all. When you do this stuff, it'll always give you that kind of thing. And then what's it doing? So then it's turning into a array from scores. Oh, so then it's turning a float 32 array into an array. And then map si. Oh, so turning it into an array of objects, I bet. So I'm just going to skip ahead. Here we go. So scores is going to be an array of objects. There we go. With the score and the word to make it easier, I presume. Then, and then it's going to sort it. So the most highest probability is at the top. Boom, boom. And then it's going to get, so now the highest probability is at the top. So 1. You can see it also thought that there was a 0.0000005% chance. I said 9, right? So it still told me that, and then it's going to print that on the screen. I think there you go, 1. It's probably going to do that again. Okay, that's how that works. Excellent. Up. Or whatever. That's fine. So then you can see that's what's happening here. That's how it's working, and that's kind of quite useful to know actually. So now I know that as well. Let's move on to the next section, which is here we go. Hey, we just did this. We tested the prediction, and then okay. Now we're going to go into, I think, the different one here, isn't it? So this is now going to train a model to recognize 3 different commands: left, right, and noise, which will move the slider left or right. Oh, I see. Okay. Okay, so we're probably just going to listen for left and right, and then move a slider left and right. If you say left, move the slider left, move the slider right, move the slider right. And we do also need to recognize, it needs to know when there's just noise. Like that. Let's now... Okay, it's just giving me a whole bunch of stuff. I'm just going to paste it in. Let's not overthink this too much. Go into my index.html. I presume here. But inside the body tag before the div console. Okay, so before the div console. Excellent. Excellent. And then what is it asking me to do? add this to index.html. Just to help. This is how I this is how I code. This is proper Stack Overflow coding here, isn't it? Just gonna drop it everywhere. Ooh, I probably wasn't supposed to delete everything. It says remove predict word. Remove predict word from app. Oh, remove predict word. Okay. Alright, so am I just supposed to add it there? Am I supposed to get rid of predict word? I think I'm supposed to get rid of predict word. I'm just going to get rid of. I'm just going to comment it out, right? For now. Okay, so now we've got a whole bunch of things, new things happening, and I'm actually not 100% sure what it's supposed to do. Oh, this is doing what I want it to do. Excellent. So, okay. So what this is going to do is we're going to train it. This is actually doing what I actually wanted to do, which is to retrain a model with OK Asim, but we're retraining it with left, right, and noise. Let's do what they want to do, and I'll do what I want to do later on. All right. In fact, let's just see it running like this. Let's get rid of all those breakpoints. There we go. There's some buttons there. There we go. Left, right. Ah, interesting. Very interesting. Okay, I like this. I like what's going on right now. Okay, let's give this a go. Let's break it down. I'm going to read it. I'm going to read instructions. Let's break it down with 3 buttons. We've seen that. Whenever we press the buttons, it calls collect. Yeah, on mouse down, collect 0, 1, 2. So left, right, noise. Left is 0, right is 1, noise is 2. On mouse up, collect null. Okay. All right. Fine. I think we're going to have to drop a breakpoint here. Okay. Oh, this is interesting to know. Okay. This is all right. I think let's read it. Collect associates a label with the output recognizer listen. Since include spectrogram is true, recognizer listen gives the raw spectrogram for 1 second of audio divided into 43 frames. Oh, okay. So 1 divided by 43. Okay, so that gives you 23 milliseconds of audio. Okay. All right. Okay. So recognize and listen is going to call us back. Every time it calls us back, it's going to call us back with 23 milliseconds of audio. Gotcha. Since we want to use short sounds instead of words to control the slider, we are taking into consideration only the last 3 frames. Subarray frames. I think I have to look at the code in a second. To avoid numerical issues, we normalize the data to have an average of 0 and a standard deviation of 1. In this case, the spectrogram values are usually large negative numbers around a deviation of 10. Oh, okay. Okay, I think I can explain this, but I need to read it first. Finally, each training example will have 2 fields, label, vals, and we restore the examples folder. All right. Examples variable. All right, let me look at the code myself, and hopefully I can explain it. So, okay. So whenever you press one of those buttons, like collect, remember collect left, we call collect with 0. That's going to call collect with 0. If the recognizer is listening, it's going to stop it listening. Whatever. It's going to label it null. No. Recognizer.listen. Then we've got the async. It's going to pass an async function. Uh, spectrogram, frame size, data. Spectrogram. Oh, it's destructuring. Okay, right. Damn, this is complicated. Okay, so I'll explain this, and we need to drop a breakpoint in here to really show what's going on. Vals num frames. Where's that? Ah, num frames. Okay, here we go. So 23 times 3, 69. Okay, so it's grabbing 3 frames. Vals, normalized data, subarray. You know, to teach this, I would definitely make it longer. I think they tried to do quite a lot in kind of one line of code. And then, okay, then that gets the raw values of the data as numbers pushed on. Okay, let me do what I like to do, which is drop a breakpoint. If you don't debug, learn how to debug. You are going to become much better developers once you learn how to debug. Okay, so we're going to understand a lot more what's going on. So let me go back into here. Let's refresh. I'm going to reload. And let's click left. Okay, so it collected one bit of data, 0. Well, I called it actually. Then it listened to some data. Oh, you fool, Asim. Okay, so that is doing some destructuring. And I'll break it out so it's not doing destructuring so you can see it a little bit better actually. Why is it doing the async? So you can pass in a function. Man, I think there's some new JavaScript here for me. So frame size and data. So it's basically, this is getting past something and it's extracting from that frame size and data. So it's 232 frames, which is, each frame is 23 milliseconds times 232. That means 5 seconds worth of data. I think it's sending us back 5 seconds worth of data. Because the frame size is 232. Okay. And so looking at the data, it is almost 1,000 values. And each of them, okay. All right. So I think if we plotted this, like if you plotted this, you know, it's just a whole, this is just a one-dimensional array. I think if you just plotted this, you know when you see sound, and it's just like you see sound like that. That's just like a series of numbers, isn't it? I think that this is just that over a large array, over a large time. Well, this is 0 for pretty much bloody everything. Am I going nuts? Oh. Do you know what? I'm going to... Because I must... I didn't say anything, that's why. Okay, let me do it again. Left. And it's going to start listening from this point. Okay, so I'm going to jump to there. Fine. And then it's going to listen for 5 seconds. So I'm going to just say 1, 2, 3, 4, 5, and we'll see if that works. Got another debugger there. Okay. 1, 2. Okay, I was clearly wrong. That was just kind of 1 second's worth of data. All right. Frame size is 232. Let me go back to the docs. Go back to docs 2 seconds. Let me reread what it said. Since include spectrogram is true. Where is include spectrogram? Oh, here. Okay. Okay, include spectrogram is true. raw spectrogram for 1 second of audio, divided into 43 frames. Divided into 43 frames. Oh, and the frame size is the number of milliseconds. Maybe the number of... Yeah, 23 milliseconds. Maybe there's 10 items. Okay. Fine. And then the data just... all of that's kind of time sliced up. So if I now look at data, I was speaking. So I do expect... Damn it. Still not. How did I comment out the whole... Miguel asked me, how did I comment out the whole function? You just do, on my computer, command and then backslash. I think. I can't remember. I just do it all the time. But let's take a look. This, hang on. Yeah, anyway, that's the data. Let's just move on. And so what I'm going to do is going to get the frame size multiplied by the number of frames. Oh, I see. Okay. Frame size times number of frames. Oh, I see. Okay. I think I'm being a bit dumb right now. I can't quite figure it out. So each frame... I think I see. Okay, so we're then there's 43 frames in a second, if I'm right. Where's the doc's gone? So there's 43 frames in a second, which means that we are going to grab 3 frames worth of a second. So 3 divided by 43. So we're grabbing 0.07 of a second. 0.07 of a second, so not a lot. And that's just the values that we're creating. So interesting. Okay, that's the values that we're creating. And then, oh no, this is the rust. I'm not debugging in that. I'm debugging in this. All right. And then I'm going to push that onto my examples. 1. Oh, of course. So the label 0 is left. Okay. Left is 0. And the collect 0 is left. Examples.push. I'm passing in a series of vowels. Right. There we go. Oh, it has normalized it as well. That's interesting. Okay. Awesome. All right, and then this is basically the training data that we're going to be training on. So 0, 1 unit is this training data. Now why the numbers is because it's also passing it through this normalize function, which if we go into here, it's going to take for every item in that list. It's going to add 100 to it. Okay, so mean is minus 100. So you know the mean is the average. We want the average to be closer to 0. So if the mean is usually minus 100, by adding 100 to it, it makes the values average. By adding 100 to everything, the values average becomes close to 0, if that makes sense. Hopefully that makes sense. And then by dividing it by standard deviation of 10, you then kind of like, if the range is this big, it's going to make the range this big. So what that's basically telling me is the data is basically like this. Here's 0 maybe here. The data kind of averages like this. What we're doing here is we're making the data like this and kind of average around 0. And that's what normalize is doing there. It depends. I imagine a lot of it depends on your microphone, your setup, and they just chose something from their values. We could probably, if we were doing it properly, we'd probably calculate it ourselves from our own data. So imagine that's what they're doing. And then it's going to print some... Yeah, it's just going to collect a whole bunch of data. So I think if I... In fact, because I've got debuggers everywhere, it's not going to do a good job. So let me... No, I can also just close debuggers and just, yeah. So is this collecting, and I should probably be making sounds right now, like ah, oh, oh. For noise, you probably want to collect background noise and not you talking, because it's trying to figure out if that sound in the corner is a human voice or if it's just some background noise. So you need to collect that as well. Ah, oh. Starting to feel maybe okay Asim is going to be like a like a tone instead of a word. But we'll see. We'll see. We'll never give up. So that's so that's what that's doing. Okay, I think that's what this example is doing so far. Let's now go back into the, where are we? 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 Here we go. Breaking it down, breaking it down, breaking it down. So I think I've explained everything here actually, hopefully. We're just collecting some data. That's all we're doing, collecting data. Let's whack it into the next one. After testing data collection, you will throw your samples away, so don't waste time collecting too many. That's a good one. So basically start the web server, make a consistent sound repeatedly or continuously while pressing and holding each of the for 3 to 4 seconds. You should collect 150 samples for each label, snap fingers, silence and talk, and alternate between silence and talk for noise. Okay, maybe I should have spoken. Yeah, okay, cool. Well, there's nothing we can do because we're just collecting data there. We need to actually train the data. So what we're now going to add a train button after the noise button. So let's go back into there. So let's go here. After noise, let's add a train button. There we go. And that's on click. I'm going to call a train function. So it's must be a train. Oh, it's a big one. It's a big one. It's going to need a lot of explaining. A lot of explaining this one. I'm going to drop that one just above app there. Oh, it's a big one. It's a big one. It's a big one. All right. Let's check this out. I know what's happening here. Very interesting. Very, very interesting. Okay. So, and then in the app says call build model. Here, I'm going to call build model. All right. Breaking it down. Oh my god. I probably am not going to explain it to the depth they're going to explain it, because the eventual app that we're going to build, I'm probably going to use it do it a different way. But what I will do, I will broadly explain it. So here we go. So when the app loads and we do that, ensure the speech commands model is created. It then calls build model, and this is the actual TensorFlow model. When we talk about model, we talk about machine learning model. And I'm not going to go into this one. There are other lectures of mine where I talk about that. But essentially, and I will talk about this in the future lectures. I promise. But for this one, it basically is creating a model, a sequential model, which is kind of like layers of things. And what this layers take is as input, it takes what happens in this model. This is what happens in the model. Okay, remember that data, the audio data was just a whole bunch of numbers on an array, right? We take that as an input, right? And then we kind of do some sort of mathematics, and there's various things to talk about. There's some sort of mathematics to kind of combine that into a smaller thing, 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 until at the end, remember, we're only detecting 20 words. We just want it to give us the end of it. It's just going to be an array of 20 things, and each of those is going to have a number inside it, and that number is going to be the probability. It's going to be that thing that I showed you earlier on, which is like that output, and it's just the 0 to 19, and for each of 0 to 19 it had a probability 0 to 1. That's the output of this model. And that's really what's happening in the machine learning model. You're giving it that raw data of just like the raw sound that's being made, and it's crunching it, and it's coming up with a probability about, well, what word was said. So that's the magic, that stuff that's happening in the middle, and that's what we call the model. And this is the model here. So there's actually quite a lot to go into. I won't go into it here, but we're using what's called a convolutional model, and you're just adding layers onto this, which all those layers are doing is taking that big data, crunching it a little bit, crunching it a little bit, crunching it a little bit, until you eventually output in the final one a layer. Okay, and you can see this is the last layer here. This is the first layer here, and that takes in the size. The input shape is number of frames 232. 1. Oh, number of frames is 3. 232, so it's 3 frames of data, which is that 70 milliseconds of data that we're collecting for each one. So that's kind of what's coming in, right? Like 1,000 sound values for a 70 milliseconds worth of sound. And the output shape, the output thing, is a layer, and you can see here it's got 3. So remember what they're doing here in this one is we're just trying to detect left, right, and noise. So it's only got 3 things. So what's going to come out at the end is it's going to be left, a probability of the sound being a left, right, probability of sound being a right, noise, probability of being a noise, right? And that's what it's basically going to do on all 3 of those. It's going to output a 3 thing, and that's all the model. That's all it's doing, right? That's all it's doing. There's a lot of maths. There's a lot of stuff happening behind here, but that's all that it's doing. And actually, it's not that hard. If I had like 2 or 3 hours just to focus on this, I could definitely explain this to you. Maybe a day. Maybe I could explain it to you in a day. And then what we're doing is an optimizer. We're using the Atom optimizer, and this is kind of compiling it. I mentioned this word categorical cross entropy. That's kind of the thing that the method of it calculating. And then that's what build model is doing. That's all that model is doing. It's kind of creating this model object, which I presume is global or something. There it is, global there. And then we're going to hit the train button, right? That's going to do something. And all that the train model does is we're going to collect a whole bunch of data for left, right, and noise. We saw you that before. We're collecting all that data. And when we hit train, remember all that data was stored in this examples variable. We're going to take that, we're going to stick it in here. And I'm not going to explain this because actually what I'm going to do is I'm going to get you to train one, save it. So you don't need to know how it trained, save it. And then I want to use it. I just want to use it. I don't want to. You're only ever going to have to train it once to create your model. Then you're going to save your model. Then you're going to use your model. And that's all you're going to do, right? You're not going to have to do this every single time for this example. So I'm not digging into it super detailed. And so yeah, so again, you get the examples. And then we're going to create the tensor model fits, and it's going to do the actual numerical number crunching, and then it's going to be done basically. It's going to calculate it, then it's going to train that model, right? So that's what's going to happen. So now, if I refresh to make sure I've got the right thing, let's get rid of that. Let's collect some data. I'm going to do blah 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 some good training data there, and then I'm gonna click train. Let me where is console? Let's open. What was that? I'm going to click train. Let's give that a go. I don't know if it's working. Is it working? There it is. It's working. So now what it's doing is an epoch is going through all of that data once. Is one epoch. And then every time you train it, that model, every time you put the data through and you train it, and we'll go through that later on, another session, it becomes better and better. It's like training, like learning, right? The more you learn something and you practice it, the better you get, the better you get, the better you get, the better you get. And that's what's going on. Every time it goes through each epoch, each lesson, it's the same data. It just gets better and better and better and better and better. And the accuracy tells us how good it is. So right now it's 99.2% accurate. All right. We still can't use this model yet in this example, so I presume they've got something else here. Yeah. Update the slider in real time. Now that we can train a model, let's add code to make the predictions in real time and move a slider. Add this right after the train button in index.html. Okay, here we go. There's the listen. It's going to be super exciting stuff, this. I'm excited. Are you excited? I'm super excited. Okay, so then we've got another button when it gets clicked, we're going to call listen. Then we have an input slider. So let's have a look what that looks like. Yeah, like a slider like this. So when I go left, it's going to go that way. When I go right, it's going to go that way, hopefully. And then it's going to ask me to... Oh my god, a whole bunch of code. Oh, yeah, but this is code that we recognize. There's a recognizer listen. Remember that? We were using that, remember? Okay, so let's grab that. And I'm going to put it somewhere here. No, here. Train, build. Should stick it right at the end. Boom. Man, a lot of code. Let's give it a go. And so, when I'm going to train, and then eventually I'm going to call listen, which is going to call listen. So that's the only thing we've added is this kind of listen function. Some of this stuff we've seen this before, right? We had this before. If recognizer is listening, then stop listening. It's doing some UI stuff. Then it's going to call recognizer.listen. Remember we had this. It's going to give us a frame size and data. So it's going to give it's the same as we're doing with collect. We're going to collect some data, and then we're going to do the same thing we did before. We're going to get 3 frames of data, which is 70 milliseconds worth of data. We're going to create a tensor. Okay. Input shape. Yeah. So the input shape is the data itself, right? It's number of frames, which is 3. 2, 3, 2 is the sizes of the amount of data in each frame, kind of each. So it sounds like every millisecond we have 10 items, and 1 you can forget about 1. One's just an extra value there. And so then we're going to have a tensor of. I've lost that where I am. Damn it! Do you know what I'm going to do? I'm just going to do this. Train, listen. Here we go. So that's just shorthand for this, right? Okay. So, we're only the way this stuff was trained is we had lots and lots of different examples. So then you had like the first value would have been like 500. How many samples we had? We had 500 samples. We had that many samples. We're only going to have 1 sample here, right? 1. So that's why it's 1. But the rest of it's the same. It's 3 frames and 232 each second. So we're going to take that data and it's going to reshape it into a multi-dimensional array that looks like that, right? One row, this columns, this cells, this, it's kind of, once you get into multiple dimensions, English words don't really, there's no human language terms can explain it. So you talk about the dimensions here. All right. Once we've got our data, we've got our model, and our model has now been trained by this point, and we give it our data, and it gives us back a probability. Remember that probability we had before, like for 0, 1, and 2, it's going to tell us what the probability of each of it is. And then it's going to move the slider by some label. Let's just try it out first, and then I'll drop a debug statement in, and we can see it working. So theoretically, ooh. Oh, that's fine. I replaced that, so I don't think that should happen. Okay, good. So now we have to do the same thing. We have to collect some data. So let's do data. Oh. Now let's train it. So now we've got those data sets. Let's train it. And remember, it's going to go through 458 examples, going to pass through each one. You can see the accuracy increasing. So every time it passes through, it's going to increase. And you can see past few epochs, it didn't increase any better. Like the accuracy kind of maxed out. And then we kind of know it's done a good job. So hopefully now, I can't remember what my noises were. Oh, 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 I'm going to remember my noises. Let me do my noises again. Okay, how am I going to remember my noises? Low is left, high is right, okay? I probably shouldn't choose a tone because I'm really bad at singing. So maybe I should just say, what can I do consistently? I can't think. A word. Word. I'm going to do low. Oh. Now let's train. It's getting to be exciting. It's getting exciting. 99%. Excellent. Listen, low is left. Okay. Oh. 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 I think because my voice goes up at the end. Oh. Oh, the background noise. The background noise is making it go higher, isn't it? Oh. Damn it. Oh. 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 Yes. All right, everyone. We did it. We made it. Okay, so actually not too far away, I think, from OK Asim. I think we need to do some other stuff to get OK Asim working. We probably need to have a larger frame size, which I now predict is probably not going to be that easy. But let's give it a go, and probably need to train it a lot more, I imagine, as well, to get that working. But let's give that a go. Let's see if there's anything else in this I missed out. Testing the final app. Done. Okay, excellent. Boom. So we went through it, and you saw it working. Let's one more time. Oh, oh, oh. Oh, yes. Oh, yes. All right, so I think that's it for today. Oh, yes, what I wanted everybody to do. The reason I was doing this, and one of the things I think I'd really appreciate if you were to support me, is I actually have a Kickstarter. Boom, boom, boom. Excellent. Let me kill that. Uh-oh, that should not have been the view I'm supposed to send to you. Let me open up in incognito. So I have a Kickstarter that I'm running. Damn it. Why do you... I don't want that. I just want... No. Just give me... that. I don't want the dashboard. That's what I want. I've got a Kickstarter. Okay, Kickstarter. I'm halfway through today. And in this Kickstarter, I'm going to be teaching people how to do this and a whole load of other things. So if you want, feel free to come support my Kickstarter. So it's called, and I'll paste it here as well, it's called Machine Learning in JavaScript for Absolute Beginners. I'm going to paste it in here in case anybody wants it. And yeah, feel free to support me if you're interested in more. I'm going to be running a few more of these sessions, a load of these sessions actually, to kind of teach you machine learning, which is a fascinating topic. But thank you very much, and I'll catch you next Friday when we're going to take it a little bit deeper and see if we can actually create it or actually teach it to learn OK Asim. All right, bye. Now the awkward part where I try and shut down the thing. Finish. Bye-bye.